Hello guys, my name is Phil once again. In this video, I'm gonna teach you about stack and queue, but for this part, I'll teach you about stack. So let's get started. Okay, what is stack? Stack is one of the most important and useful non-primitive linear data structure in computer science. You can say stack is an ordered collection of items into which new items may be added or inserted, and from which its items may be deleted at only one end, which is called top of the stack. As all the addition and deletion of items in a stack is done from the top of the stack, the last added element will be first removed from the stack. That's why the stack is also called last in, first out, or LIFO. There are some basic operations, primitive operations performed on the stack. For example, push, pop. These are the primitive operations that we can perform on the stack. What is push operation? Push operation is the process of adding or inserting a new element to the top of the stack. Pushing an element to a stack will add the new element at the top. After every push operation, the top is incremented by 1. If the array is full and no new element can be accommodated, then the stack overflow condition occurs. So there should be a way to handle the stack overflow condition. Another primitive operation is pop. Pop is the process of deleting or removing an element from the top of the stack. After every pop operation, the top of the stack is decremented by 1. If there is no element in the stack and the pop operation is performed, then the stack underflow condition occurs. Again, you need to have a way to handle stack underflow condition. The insertion or the addition operation is referred to as push operation, and the deletion or remove operation is known as pop operation. A stack is said to be empty or in underflow condition if the stack contains no elements. At this point, the top of the stack is present at the bottom of the stack, and if it is full or in overflow condition, that is, no other elements can be pushed onto the stack, we say at this point the top pointer is at the top or at the highest location of the stack. How can we implement stacks? We can implement stacks in two ways. One is static implementation, which use arrays, and the second one is dynamic implementation, which use pointers. Let's look at the static implementation. Static implementation use arrays to create stack. Static implementation using arrays is a very simple technique, but is not a flexible way, because as the size of the stack has to be declared during the program design, after that the size cannot be varied or changed. You cannot increase or decrease the size. Moreover, it is not an efficient method when resource optimization is concerned, like the memory utilization. Let's take an example. A stack is implemented with array size 50, which means an array which can store 50 elements. That is, before the stack operation begins, memory is allocated for the array of size 50 elements. Now, if there are only few elements, let's say 30 to be stored in the stack, then the rest of the statically allocated memory, in this case 20, will be wasted. On the other hand, if there are more number of elements to be stored in the stack, let's say 60, 70, or 100, then we cannot change the size of the array. We cannot increase its capacity during the runtime. What we can do is we can fix it during the declaration, but it is not flexible. All the above said limitations of static implementation can be overcome by dynamically implementing the stack using pointers, which is also called linked list representation. We will discuss it in chapter 3. Note that the most frequent accessible element in the stack is the topmost element, whereas the least accessible element is the bottom of the stack. For example, let's illustrate stack operations as following. Originally, the stack is empty and top pointer is pointing to nothing. If you add a new element, the new element will be at the bottom, and now the top pointer is pointing to the bottom. If you again add in another new item or element, it will be on top of 20 and top pointing to the new element. Push another element, it will be on top. Top is pointing to the most top element, which is 47 now. If you perform delete operation or pop operation, the most top element, which was 47, is removed from the stack, and now top is decremented by 1, which is now pointing to 33. If you add another new element 77, it will be on top of 33. Now top is incremented by 1 and pointing to 77. Delete operation deletes the most top element, which is 77. Now top is pointing to 33. Again, delete operation, 33 is removed and top is pointing to 20, which is the bottom element of the stack. This is how it works graphically. Now let's discuss the algorithm. We have two operations, push and pop. To push a new item, first we need to check whether the stack is full or not. In order to check whether the stack is full or not, let's use this condition. If top is equal to size minus 1, it means the stack is full. Then we have to display a message to the user saying the stack is in overflow condition, then exit. Otherwise, if it is not full, if the stack is not full, increment top by 1, then assign the new item at the top position of the stack, then exit. For pop operation, check whether the stack is empty or not. Pop is possible when there is at least one item in the stack, so we need to check whether the stack is full or not. In order to do that, we have to use this condition. If top pointer is less than 0, it means if it is negative, the stack is empty. Therefore, we have to display a message for the user saying the stack is empty. Then exit. Else, we can remove the topmost element. Therefore, we have to assign the topmost element of the stack to a temporary variable data. Then decrement top pointer by 1. then exit. This is the algorithm. Okay, now let's see how we can implement stacks using linked list graphically. But we will see the algorithms and more detailed concepts in chapter 3. So this is simply for overview. If you want to push a new item, an item of a stack has two parts. One is the data field and the address field. We also have the top pointer, which points to the top most element. So if you push 10, top is pointing to 10 and 10 is pointing to null. It means 10 pointing to null means there is no next element to 10, or 10 is the bottom element of the stack. We again push 20. 20 is now topmost element, which means there is a next element to 20, which is 10. That's why 20 is pointing to 10 and 10 is pointing to null because there is no next element to 10. We push 30. 30 will be the topmost element. Therefore, top should point to 30, 30 to 20, 20 to 10. If we perform pop operation, the most top element is removed. Now top is pointing to 20. If you again push another item, 40, 40 is top element, 40 is pointing to 20, 20 is pointing to 10, and 10 is pointing to 20. This is how stack is implemented, or how stack works using linked list or using pointers.